Hey everyone, so it is the last lesson before Christmas break. The topic is called Decomposing into Partial Fractions. That sounds pretty intimidating maybe. Um, the math we're going to do is not difficult math, but there are a lot of steps, a lot of parts to it. Essentially, it's the exact opposite of what we did yesterday. So yesterday we took a problem like this: 5 over x plus 2 plus 3x over x plus 1, and then we combined them. And the way you combine them is to find the common denominator, which in this case would be x plus 1, x plus 2. You multiply that by each fraction as needed. Then you combine them. And on yesterday's assignment, we stopped right. No, I take that back. We did one more step. Well, yeah, we kind of stopped. I guess it would look kind of like this: 3x squared plus 11x minus 5. So we'd simplify the top and then left the bottom in this form. If, however, you continued to simplify the bottom by foiling all this together, you could eventually get to an answer like this one. So you should understand how to do that if you need to. Anyway, that was the main idea yesterday. So we start with a problem like this, and we do the work until we get an answer like that. Today is just the opposite. We're going to start with this and figure out how to work backwards to make it look like that. So it's like everything in math. You learn how to do something, and then you learn how to do it backwards. It's always been that way. If you think about it, you learn adding in kindergarten, and then you learn subtracting, just the opposite. Multiplying and dividing, squaring and square roots. You learn straightforward math like what is 5 plus 3, and then you learn algebra. 5 plus what equals 8. So you learn how to, think backwards through math. It always works that way. Logarithms and exponential functions, everything, it's always full of opposites. So that's what we're doing here. We're going to start with this and find out what two fractions could add together to give you that answer. Now, there are a few different methods to do what I'm going to teach you today, and depending on how difficult or complicated the problem is, you choose the method you want. This is just an introduction to the topic, so I'm only going to keep the problems in one sort of simple form, and we're only going to use one method. So I'm not going to teach you a whole bunch of different things today. I will tell you that 1 through 6 work one way, and then 7 through 10 work a little differently. So if you're the type to stop after the first example and do your homework, I just want to warn you, things will change a little bit when I get down to problem 8, so when you get down to problem 7. So you might want to, instead of stopping after the first one problem or two problems, skip ahead to see either number 8 or 10. They're very similar. So watch those as well. Okay, so here we go. Decomposing into partial fractions. Here's what you do first. First, factor the denominator. You do not need to factor the numerator. You can't in this problem, but even if you could, you wouldn't. You only factor the denominator. Here we're going to do reverse FOIL factoring. So x and x, and I think plus 3 minus 2. They multiply to negative 6, and they add up to positive 1. So there, it's factored. That's always going to be your first step, and no matter what, you have to do that. Second step, we're going to make two fractions out of this. One fraction is going to have x plus 3, one part of the denominator, and then the other fraction is going to have the other part, x minus 2. Of course, both those fractions will have numerators, but we don't know what they are. And you can't say, oh, it's going to be 20 and 10, because 20 plus 10 is 30. No, it doesn't work like that, because just no. You wish it would be that simple. Not a snowball's chance. Just not going to happen. So what you do is you say, I don't know what the numerators are. I'm going to call this numerator A and this numerator B. Okay, now I'm going to shrink this down a little bit because I need just a little more space to do my writing. That didn't do anything at all. There, that should be good. Okay. Here we go. Multiply this whole equation by the common denominator. So we're going to multiply the whole thing by x plus 3, x minus 2. Oops, 2. So we're going to use the distributive property. We distribute this all the way to here, and it's going to make those cancel out, and you just get 30. Then you bring down the equal sign. You distribute it to here, and the x plus 3 is going to cancel out with that x plus 3. It's going to leave you with a x minus 2. So the a end up getting multiplied by x minus 2. Bring down the plus sign, and then when we distribute it to this term, the x minus 2 is what's going to cancel, and we end up with b x plus 3. Now this is a process we've already kind of done before. In a way, it was called clearing the denominators when we solved rational equations. So we've not really done anything new yet. It's just a series of steps put together in an order that you probably haven't seen before, because this is just a brand new process. Okay, this equation is going to be important. We're going to come back to that. But now we are going to do a couple processes of substituting values in for x. Our goal, again, is to solve for a and b. We want to know what a and b are. So you are going to plug a value in for x. What number do you plug in for x? Well, we're going to plug in values that would make this turn into 0 and that turn into 0. So let's focus on the x minus 2. What could we plug into x minus 2 to make it equal 0? That's going to be a positive 2, right? 2 minus 2, 0. So we have 30 equals a times 2 minus 2 plus b times 2 plus 3. So we plugged this 2 here and here. Now, when we work this out, we end up with a times 2 minus 2. Well, that's a times 0. Plus b times 2 plus 3, that's b times 5. So we end up with 30 equals, that goes away, 5b. Divide both sides by 5, and we get b equals 6. Now remember, our ultimate goal is to solve for a and b in this problem, and we've just solved for b. So in a sense, we're halfway done. Now we need to kind of repeat that process, but this time we need to plug in whatever number will make x plus 3 equal 0. And that, I hope, is obvious to you, is going to be negative 3. So we get 30 equals, so I'm going back to this equation right here. 30 equals a times negative 3 minus 2 plus b times negative 3 plus 3. So I plugged this 3 in here and here, and we're going to work that out. 30 equals a times negative 5 plus b times negative 3 plus 3 is 0. So that means 30 equals negative 5a, because b times 0 just goes away. Divide both sides by negative 5, and you get a equals negative 6. Now we know what our final answer is. Remember, our answer was something over x plus 3 plus something over x minus 2. Right up here. I got so many lines and highlights and stuff, it's hard to see. So we are trying to figure out what a and b is in that thing right there. So a is negative 6. That means I put a negative 6 here. And b is positive 6. I put a positive 6 there. And this is it. If this was the answer to what we did yesterday, this would have been the original problem. Let's go down and check that and make sure I didn't mess it up. And there's already check marks because I already did this worksheet once without recording, not by mistake, but because I wanted to make sure I did them right. So yes, number 2 is good. Okay, so some repetition should make this a little better. If you're unclear, chances are you were able to follow all the math. I mean, all I did was add, subtract, multiply, divide. Not difficult math. You just got to learn what the steps are and how you put them together and make it all work. So let's do this next one. It's going to be a little more complicated because there's a variable up here, whereas in this problem there was just a number in the numerator. But it's honestly not that much more complicated. I think you'll be fine. Oops. Okay, so first thing you want to do is factor the denominator. The numerator does not change, and you can't factor this one anyway. Even if you could, you wouldn't factor it. And this becomes x And I think plus 2 plus 1, right? 2 times 1 is 2, 2 plus 1 is 3. So our final answer is going to be something over x plus 2 plus something else over x plus 1. If this is the answer, the original problem would have to look something like that. We just got to figure out what are A and B. So take this whole equation here and multiply it by the common denominator, x plus 2, x plus 1. When we distribute to this term, both those factors cancel out. You get negative 6x minus 13. When you distribute it here, the x plus 2 cancels out. You get a x plus 1. Bring down the plus sign. When you distribute it here, the x plus 1 cancels out. You get b x plus 2. So this is kind of a crucial step that you're able to get this line right here. Now we need to plug in values for x to make the x cancel out. What could you plug into this term to make it cancel out? X plus 1. If you plug in a negative 1, that will make that a 0. So what you have to do is plug in negative 1 to all x's. This one, and that one. All right, getting highlighter happy here. I need to clean this up a little bit. Okay, we'll go with that. One highlight is enough. So negative 6 times negative 1 minus 13 equals a negative 1 plus 1 plus b negative 1 plus 2. All right, if we simplify this, negative 6, I'm looking right here. Negative 6 times negative 1 is positive 6. Positive 6 take away 13 is negative 7. Sorry about that. Negative 7. For this part, negative 1 plus 1 is 0. Instead of writing that down in a step, I'm just cross it out. I mean, that's gone. That's a 0. And then over here, b times negative 1 plus 2, that's going to be, what's negative 1 times 2? Negative 1 plus 2 is positive 1. Positive 1b equals 7. Well, duh, divide by 1. b equals negative 7. There's my b value. Now let's find a. What do I need to plug in to make this cancel out and go away? Well, x plus 2, it's going to take a minus 2, or negative 2. So we get negative 6 times negative 2 minus 13 equals a times negative 2 plus 1 plus b times negative 2 plus 2. So I plugged this negative 2 in for all three of those x's. And what happens now? Negative 2 times negative 6 is 12. 12 minus 13 is negative 1. A times negative 2 plus 1. Negative 2 plus 1 is negative 1a. And negative 2 plus 2 is 0, so that term disappears. Divide both sides by negative 1. Negative 1 divided by negative 1 is positive 1. So now we can go to our final answer. A over, oops, there's a reminder that I have a meeting. Oh well. A over x plus 2, not equals, that would be plus b over x plus 1. A we calculated to be a 1, b we calculated to be a negative 7. Let me go down and check the answer to number 4, see how that looks. Okay, so my answer is a little different, but mathematically it's actually exactly the same, because hopefully you remember, oh, where am I? Here we go. You remember that when you add a negative, it's the same thing as subtracting. So this is the same as 1 over x plus 2 minus 7 over x plus 1. Same answer, just bring that negative down here. Remember, a positive times a negative equals a negative. So there you go. All right, so there's a couple examples. Number 6 will be kind of similar, maybe a little different. And then, as I said before, 8 and 10 are going to be a little more significantly different in the way they're structured. All right, number 6. So again, you don't have to factor the top. It won't make any difference at all, but you do have to factor the bottom. And so this is going to become a over x plus b over x plus 2. So we know that this is going to split into two fractions. What are they? We don't know. So a and b are unknowns. Multiply this whole equation by the common denominator right here. So x plus 2. When you distribute here, that cancels out. You get 3x minus 6. When you distribute here, the x cancels out, leaving you with ax plus 2. And when you distribute here, that cancels out, leaving you with bx. Now, we need to plug in numbers for x. What would make this term disappear, or that factor disappear? X plus 2, it's going to take a negative 2. So if we plug in negative 2, we get 3 times negative 2 minus 6 equals a times negative 2 plus 2 plus b times negative 2. Now we simplify this. 3 times negative 2 is negative 6. Negative 6 minus 6 is negative 12. A times negative 2 plus 2 is 0, so that goes away. B times negative 2, we'll just call that negative 2b. Divide both sides by negative 2, and b works out to equal 6. So we've got our b value. Now let's look at this term. What could we plug in there to make that equal 0? Well, it's quite simple. 0. If you plug 0 in for x, it turns into x. Or it turns into 0, sorry. So we get 3 times 0 minus 6 equals a times 0 plus 2 plus b times 0. 3 times 0 minus 6 is negative 6. 0 plus 2 is 2. B times 0 is gone. So what I have here is negative 6 equals 2a. Divide by 2. A equals negative 3. Now that we have a and b, we can make our final answer. So something a over x plus something, which is b over x plus 2. The a is negative 3. The b is 6. That should be the answer. I say should be because every once in a while, I make mistakes. But there it is. You see that I have the negative up here. The answer key brought the negative down there. That's actually much more proper when you have a negative in a fraction to bring it out front. So I'm just going to change my answer, make it look like I was right the whole time. Okay. So, as I said, these do get worse. These are not the bad ones. If you get into the second semester of calculus, let's say in college, you will learn how to do this plus some harder ones, and then you will use this as one step in solving bigger calculus problems. Just saying, that's how it is. All right. This next one, you'll see why it's different in just a moment. So if I factor the denominator, we get x and x. Now we need two numbers that multiply to 25 and add up to negative 10. That's going to be minus 5 and minus 5, right? So this is a repeated factor, and that does change things a little bit. We're still going to make two fractions here because there are two factors, 1, 2. So we're going to make two fractions out of this. And the top of one is going to be a, and the top of the other is going to be b. That's not different. I just realized I'm going to have a problem. I'm not giving myself a lot of room to work this out. So I'll do that. Okay, so in one denominator, you put x minus 5. In the other denominator, you don't put the other x minus 5. You might wonder why. Yeah, you just don't. I don't know. What you need to do is in the other one, you need to put both x minus 5s. Like that. So now we multiply the whole thing by x minus 5, x minus 5. When you distribute here, they both cancel. You get x minus 8. When you distribute here, 1 cancels with 1, and then you get a x minus 5. And when you distribute here, they both cancel, just leaving you with b. So you need both, and then they make both cancel. If you didn't have both, then these wouldn't both cancel, and then you'd have issues. So if you have a repeated factor, it goes one time in one fraction and then both times in the other fraction. Now the process you would think is the same, kind of not. So we got to plug numbers in for x. What number would make this term cancel? X minus 5, well, that's going to take a positive 5, right? 5 minus 5 is 0. So you plug that in, you get 5 minus 8 equals a times 5 minus 5 plus b. Of course, 5 minus 8 is negative 3. 5 minus 5 is 0, so 0a is gone. And then there's b right there. How about that? b equals negative 3. Now for the next step, we would look at what's supposed to be here and say, okay, what could we plug in to make that equal 0? And since there's no x there, you can't plug anything in because there's no x. You don't get to plug something in for b, you only get to plug something in for x. So what do you do? Well, the answer is you go back to this equation here, and you plug in any number for x you want. You can plug in 1, 2, 3, 4, 5, 8, negative 2, negative 100, a million. But quite honestly, the easiest number to plug in is 0. You might argue that 1 is a very easy number to work out. That's true too, but 0 is wonderful to work out when you plug it in. So I'm going to plug in a 0. You get 0 minus 8 equals a times 0 minus 5 plus b. 0 minus 8 is negative 8. 0 minus 5 is negative 5, so that's negative... Oh, wait. No, I forgot something. Ooh. This b right here is a negative 3. We already solved for that. So we can make that, instead of a plus b, a minus 3. So, okay, back on track. 0 minus 5 is negative 5. That's negative 5a. And that b now is not a b. You see, if I accidentally, what I was about to do, the mistake I was about to make, was to leave that a plus b. If that's a plus b, you can't solve because you got two variables in the same equation. You can only solve when there's one variable. But the fact that plus b is actually a minus 3, now we can solve this. Add 3 to both sides. Negative 5 equals negative 5a. Divide by negative 5. A equals negative 5 divided by negative 5 is 1. So now we can write our final answer. So remember, it was a over x minus 5 plus b over, yeah, there we go. No, that's better. X minus 5, right? So I'm copying this right here, copying that down. So my a is 1, my b is negative 3. So that's 1 over x minus 5. Remember, if you have this negative here, you can sort of bring it down there. So it becomes minus 3 over. And then finally, x minus 5 times x minus 5. You can just condense that into x minus 5 squared. And that should be the final answer for number 8. And there it is. Okay, so I almost made a mistake on that one. A minor stumble. In case it confused you, number 10 is going to work out like number 8. So if you got number 8 and you're good to go, just go to work. If not, follow along as I do number 10. Going to be very, very similar. Okay, here goes. So factor the denominator. And this one is going to factor into 5x, 5x. 1 times 1 is 1. Plus, plus, and then we get 5x, and 5x is 10x. So there it is, all factored out. It's going to turn into a over 5x plus 1 plus b over, uh-oh, I'm going to sneeze. Sorry about that. I hope you had time to get your earbuds out of your ears. Oh, geez, that last one hit me out of the blue. My goodness. Okay. Well, can't say class isn't interesting because, love it or leave it, I make things interesting. Okay, sneezing into a microphone is not interesting. Sue me. All right, so the second denominator. So one denominator is 5x plus 1. The other denominator is 5x plus 1, 5x plus 1. It's got to have both of those factors in it. Now, oops, just about did that wrong. Multiply the whole thing by 5x plus 1, 5x plus, am I running out of room? Crud. Let me see if I can make this a little smaller, a little neater. 5x plus 1, 5x plus 1. Suppose I could just write 5x plus 1 squared, huh? All right, distribute here. You get negative 15x minus 4, because those cancel. Distribute here. One of those cancels. You get a 5x plus 1 plus, and then you distribute here. They both cancel, and just gives you b. Now, what do we plug in for x? Well, this first one might not be too obvious to you. If you need to, go off to the side, 5x plus 1, set it equal to 0, and then work it out. So you get 5x equals negative 1, divide by 5, x equals negative 1/5. So we need to plug in negative 1/5. You might hate that because it's a fraction. Actually, it's not that bad. It works out kind of nice. So if you plug it in for x, you get 15 times negative 1/5, and you notice 5th and 15, those are going to simplify easy. Minus 4 equals a 5 times 1/5 plus 1. Well, we already know that that's going to equal 0. I guess I didn't make that negative very legible, so 5 times negative 1/5 plus 1. There we go. So, okay, what's going on here? Grab a calculator if you need to, but negative 15 times negative 1/5. The negatives cancel, make a positive. 5 cancels into 15 3 times. 3 times 1 is 3 minus 4. So that side works out to be negative 1. On this side, 5 times negative 1/5 plus 1, this part right here, we already know that's going to be a 0. So just bring down b, and we've got that part of the answer. So here we plugged in negative 1/5. Now we're going to plug in 0. So negative 15 times 0 minus 4 equals a times 5 times 0 plus 1 plus b, but no, don't put b. We know b is negative 1, so put a negative 1 there. So 15 times 0 minus 4 is negative 4. A times 5 times 0 plus 1. So 5 times 0 plus 1 is 0, plus 1 is 1, so that's 1a minus 1. Add 1 to both sides. Negative 3 equals 1a. Well, 1a is just a, so there's that. So our final answer had what? A over 5x plus 1 plus b over 5x plus 1, 5x plus 1. The a worked out to be negative 3. The b worked out to be negative 1. So I can write my final answer, negative 3 over 5x plus 1 minus 1 over 5x plus 1 squared. And that is that. So decomposing into partial fractions. Really an important skill in calculus. For now, you don't really have to think about the calculus aspect of it. All you got to think of it is it's what we did yesterday, only backwards. All right, good luck on this. This is the hard lesson for this week. Yesterday was the easy lesson. There is no third or fourth lesson. I will throw a quiz up for you. And remember, all this work goes on to the next marking period. If you do have any trouble, please contact me. I'll do my best to help you out in whatever way I can. Otherwise, I will talk to you probably after break. Bye-bye.